Hey, Mom, I'm Rosa Uba from BSEE 1A. So, problem set number 5. Apple number 1, 12.7, page 606. Compressive stress in a pillar is a sculpture weighing 10,000 Newton rest on the horizontal surface at the top of a 6.0 meter tall vertical pillar. Figure 12.9 in the pillar's cross sectional area is 0.20 meters squared and it is made of granite with a mass density of 2,700 kilogram meter cube. Find the compressive stress at the cross of section located 3.0 meter below the top of the pillar in the value of the compressive strain at the top of 3.0 meter segment of the pillar. So given sculpture weight, which equals to 10,000 Newton or 1.0 times 10 to the raised power 10 to the fourth power Newton. Height of pillar 6.0 meter and pillar's cross-sectional area, which equals to 0.20 meters squared. And density of granite P, which equals to 2,700 kilogram per meter cube or 2.7 times 10 to the raised power of 3 kilogram meter cube. And for A, H, which equals to 3.0 meter, and for A or the pillar cross-sectional area to 0.20 meters squared, and for P 2.7 times 10 to the third power kilogram meter cube, which is our density of granite, and for the gravity, which equals to 9.8 meters squared s squared. So that solution. To find the compressive stress is pangitaw na to ang weight of the pillar. And we must first to see the value of the pillar ay na to pangitaon ang mass. To solve the volume of the pillar, ato ni multiply ang cross-sectional area, which is 0.20 meters squared and height is 3.0 meter. And by simplifying, so Mani siya to ang 0.20 meters squared and 3.0 meter. So the pillar's cross-sectional area times the density of granite. So maani siya ato height 3.0 meter. So our height and the 0.20 meters squared. So, ano siya tong pillar's cross-sectional area. So, we can derive the answer, 0.60 meter cube. And for the mass pillar, so PV, so which is our PV is the density of granite and the volume, or the volume. So, which is the P is 2.7 times 10 cube kilogram per meter cube, then 0.60 meter cube. So mao ni ato ang volume, mani siya to ang volume. So ato rin siyang i-paste or i-write then i-times nato ni siya i-times. So or we can multiply this this equation so that maka get the final answer, or answer is 1.60 times 10 cube kilogram. For the WP equals to mg, so mass gravity, which equals to 1.60 times 10 cube kilogram, so which is the mass pillar. So muna siya, then 9.8 meter per second squared. So kuha na siya simplify and multiply so that our WP, which equals to 1.568 times 10 to the fourth power Newton. And to know the weight of the pillar, mass times gravity. So mass times gravity mo na to siya. Since we know the weight of the pillar is nakita na to ang katong WP or the mass gravity is 1.568 plus 1.0 times 10 to the fourth power Newton. So, 2.8 times 10 to the fourth Newton. So, ato rin siyang i-distribute. So, by distributing, we can get the answer 1.1 to the fifth power, or the 128.4. So, by letter B, strain stress over Y. So, since stress ato ang nakita ganina, so nakita naman natong stress, so 128.4 Pascal, so that ato ani siyang i-copy dari. So, 128.4 Pascal, so which is our stress, and for Y, Y is the modulus of granite over 4.5 times 10 squared Pascal. So, equals 2.8 times 10 to the raised power of negative 6. So, for the problem set number 2, example 12.8, page 608. Stretching a rod. A 2.0 meter long steel rod has a cross-sectional area of 0.30 centimeters squared. The rod is a part of a vertical support that holds a heavy 550 kilogram platform that hangs attached to the rod's lower end, ignoring the weight of the rod. What is the tensile stress on the rod and the elongations of the rod under the stress? So, given the original length, or the LO, which equals to 2.0 meter, and for M, which equals to 550 kilograms, so our mass, and for A, or the cross-sectional area, 0.30 squared, or 3.0 times 10 to the raised power of negative 5 meters squared. Y, which equals to 2.0 times 10 to the raised power of 11th Pascal. So, solution. By solving the tensile stress, atong gamiton ang the formula is the forming force over the cross-sectional area. So that 550 kilogram times 9.8 meter per second squared over 3.0 times 10 to the raised power of negative 5 meters squared, which is our cross-sectional area, and then ato ang forming force, which is the 5 kilogram times 900 meters per second squared. So that ato rin siyang makaderive the answer, ato rin siyang i-multiplied, or we can simplify it so that 1.8 times 10 to the 8 Pascal. So, manat na siya to ang makaderive the answer. And for the elongation under the stress, para ma-solve na to ang elongation using the original length using the 2.0 meter, we can convert this equation by multiplying and simplifying. So that 1.8 times 10 to the raised power of 8 Pascal, 2.0 meter over 2.0 times 10 to the raised power of 11 Pascal. So, ano na siya ang final answer, 1.8 times 10 to the raised power of negative the 1.8 meter per meter. So, the elongation of the rod stress. Problem set number 3, or the example 3, 12.9, page 611. So, hydraulic press. In the hydraulic press, figure 12.23, a 250-liter volume of oil is subjected to a 2,300 psi, or the pressure increased if the compressibility of 2.0 times 10 to the raised power of negative 5 sphere. Find the bulk and the absolute decrease in the volume of oil when the press is operating. So, given V, or the volume, and for P, which equals to 2,300 P for K, which equals 2 raised power of negative. So the solution for the pressure increase to 2,300 psi over the 14.7 atmosphere. So ato ni siyang i-divide. So ato i-divide, so which is maka derive tag answer 160 atmosphere. So the bulk strain. So to find the bulk strain, we need to convert the pressure increase from the atmosphere. So mana siya. Then we must to use this equation. So mana siya, equation na siya. And then the change of the volume relative to the original volume, dili na to gamiton instead of this equation. Kani siya, kaning note is 12.40. So, times by simplified to know the absolute decrease, we can multiply it by original volume. So, maroon ni siya, katong 2.0 times 10 to the raised power of negative 5 atmosphere, per atmosphere and 1.60 atmosphere. So, other rin siyang i-multiply. So, atong bulk strain is 0.0032. So, mao na siya atong volume, and then next volume is 0.78 liter. So, anong liter? 0.78 liter. And now the equation is 12.40 K, or lagi K, which equals to 1 over B equals to negative V per VO over P. So the problem set number 4, example 12.0, page 162. An old bookshelf, a clearing person tries to move a heavy old bookcase on a concreted floor by pushing tangentially on the surface of the very top shelf. However, the only noticeable effect of this effort is similar to the sun. And figure 12.24, and it disappears when a person stops pushing. The bookcase is 180.0 centimeter tall and 90.0 centimeter wide, with a power 30.0 centimeter deep. Shovels all the partially loaded with books. The weight of the bookcase and the book is 600.0 Newton. If the person gives the top shelf a 50.0 Newton, push that displaces the top shelf horizontally by 15 centimeter relative to the mounting modulus of the bookcase. So the given is F11, or the tangential force, which is the 50.0 Newton, and for the X, or the displacement, 15.0 centimeter, and LO, or the transverse distance, is 180.0 centimeter, and for A, or the area, is 90.0 centimeter and 30.0 centimeter, which equals to 2,700.0 centimeter. So, kaning 90.0 centimeter and 30 centimeter is that siyang simplified or multiplied, so that we can derive the final answer is 2,007.0 centimeters squared. So, the solution is the S. So define rather S, or the chair modulus of the bookcase, which equals to chair stress over chair strain. So the tangential force over the area, and for LO, or the transverse distance,